of trigonometric functions and finally we have boat in the river problems. Two of these concepts are pretty straightforward and one is a review from Algebra 2. So we should be able to get through this quite quickly and enthusiastically. So let's get started with angles greater than 360. Sometimes we think to ourselves, well, everything happens between 0 degrees and 360 degrees. And that's just not true. From your friendly angles, you should know that sine of 30 is 1/2. That's correct. Good job. 30 degrees lives right here on our coordinate plane. Now, what you would be surprised to find out is that after we go 360 degrees, if we go 30 more degrees, we actually have the exact same direction. That's because there's 360 degrees in an entire rotation. After that, you're at 0 degrees again and you start over. So in your problems, you're going to see something like this. Sine of 390 degrees. Be comforted to know that sine of 390, as I've shown here in this picture, is exactly the same as sine of 30. Both of those equal 1/2. How did I get from 390 or any higher number than 360 down to a number I know how to work with? I subtracted 360 degrees. So let's try some examples from the book. What would sine of 420 degrees equal? Well, our first step is to subtract 360, since this is over 360, from our angle. And we have sine of 60 degrees. What's sine of 60? It's square root of 3 over 2. If this concept bothers you, remember that a lot of things in life repeat over and over and over again. They are periodic. You think about history class, right? They always say, you should learn from history so you don't repeat the mistakes that you had before. In the Bible, we see the people of Israel consistently repeated the exact same mistakes. Why? Because they hadn't learned from what happened before. Here, excuse me. Here, we see that we have a function that has the exact same value, but with a different number coming into it. That's totally fine because just like history, just like things in the Bible, just like things in our lives, this function is going to repeat itself. The question is, are you going to know how to address that? And spiritually, the question is, are you going to know how to address that? So with that said, let's tackle a couple more of these, but with some added complication. Now, we're going to have them added together to other trigonometric functions. So let's find cosine of 135 plus tangent of, wow, this is a big number, 690. All right, our first step is to get rid of any numbers that are greater than 360. 135 is fine, so I'll leave that as is. But 690 is too large. So I'm going to subtract 360 from it in order to get a number that I know how to deal with. Do we know cosine of 135? Of course. From your friendly angles, you know that it is square root of 2 over 2. If you don't believe me, go ahead and draw out the triangle. 135 lives over here. Wow, that is not a triangle. The corresponding angle to 135, which is this one, is 45. So we can draw our 45, 45, 90 triangle. Cosine of this angle is 1 over root 2. What about tangent of 330? Well, I'm going to tell you that it is square root of 3 over 3. If you don't believe me, that's fine. We can draw out that triangle as well. 330 lives in the fourth quadrant. if this angle is 330, this angle must be 30 because all angles in a circle add up to 360. So we're talking about tangent of 30. We know our 30, 60, 90 triangle looks like this. And so opposite over adjacent, 1 over root 3. We simplify that to root 3 over 3. Now, do we have a problem adding these two trigonometric functions? No. We find out their value, and then we add as normal. So we need a common denominator, and we'll add 3 square root of 2 plus 2 square root of 3 over 6 is your final answer. Let's try one more. So, we have, oh, here we go, cosine of negative 60 degrees plus cosine of 210. So maybe you're confused by the negative 60. That's all right. We'll go ahead and draw out the graph indicating where that would be. So positive angles, we go up. Negative angles, we go down. So negative 60 will live right here. Since this is a 30, 60, 90 triangle, I can draw in the sides. And I know that cosine of negative 60 is adjacent over hypotenuse, or 1/2. For cosine of 210, if you're confused, that's fine. Although I would encourage that you memorize those values in the future so you don't have to spend so much time on these problems. Cosine of 210 would give me this angle is 210. We know that 180 goes up to here, so this angle is 30. 210 minus 180 is 30. So I'll draw in the sides of my friendly triangle, and cosine of 30 is square root of 3 over 2. Adding these together, I get 1 plus square root of 3 over 2. Okay, so evaluate each term individually, then add together. Now, the last part of our lesson is possibly one of your favorites or one of your least favorites from Algebra 2. That is the boat in the river problems. You remember you have a boat, it's in the river. This is my boat. Apparently it's a sailboat. And it's in the river, so the river pushes the boat a little bit, and the boat has a giant engine on it. And it pushes itself a little bit. So we're trying to determine distances and rates and times of this boat in the water when it is going upstream and downstream. Upstream means that the boat is going one way, but the water is flowing the other way. And downstream means that the boat and the water are flowing in the same direction. Now, since we're in pre-calculus and we are well above boat and river problems, your problems will have airplanes, which I will represent by this box with wings. And you will have wind. So if the boat and the wind are going in the opposite direction, it's still upstream. If the boat and the wind are going in the same direction, it's downstream. So what equations are we going to need for these problems? Well, the distance upstream is the rate upstream times the time upstream. Are we surprised? No. The distance downstream is the rate downstream times the time downstream. Now, one important thing to note. We're going to call the speed of the wind W. And we're going to call the speed of the plane P. So I can simplify these two terms a little bit more. So your final plane in the wind problems, instead of boat in the river problems, will look like this. Distance upstream equals, we'll talk about the rate in a second, times the time upstream. And distance downstream equals something times time downstream. Now here's the key. If you are going upstream against the wind, then you should have your plane speed minus the speed of the wind. The wind is slowing you down. So your rate is the speed of the plane minus the wind. But if you are going downstream with the wind, then you have the speed of the plane plus the speed of the wind. And those are your two equations. So let's read a problem and see if we can solve it. One day, Shelby found that her plane could fly at 5 times the speed of the wind. So as I'm reading through these problems, I want to find the equations that I can pull out of it. So if Shelby's plane is 5 times the speed of the wind, I can write the equation plane equals 5W. Next, she flew 396 miles downwind. So in this case, I'm going to say that her distance downwind is 396 because she flew 396 miles downwind or downstream. It's the same concept. We have more information now. In 1/2 hour more than it took her to fly 132 miles upwind. Now, did you catch? I missed a piece of information. They said that she traveled downwind in 1/2 hour more than it took her to travel upwind. So that's information about the times. If they were equal, TU would equal TD. But this time, it took her a 1/2 hour more to go downwind. So TD should be bigger. So I'm going to add 1/2 to TU. This tells me that I spent 1/2 hour more than the upwind time going downwind. Okay? Once you've read the problem and pulled out the equations and the information that you can find, we're going to use these two equations for the problem. So distance upwind equals plane minus wind time upwind. And distance downwind equals the plane plus the wind times time downwind. Now from here, you're going to solve these equations as you know how, either using substitution or elimination. First, I'm going to plug in all of the information that I know. So I know distance downwind is 396. I know that distance upwind is 132. I know that the plane is 5 times the speed of the wind. So I have 5W minus W and 5W plus W. Now here's where it gets tricky. I'm going to have to choose to either solve for time upwind or time downwind. Since I already have time downwind solved for, I will plug in to time downwind. So time downwind is 1/2 plus TU. Now, we have these two equations that we now need to solve. There's one more trick in these problems that you need to be aware of in order to get them right. And that is as follows. If I evaluate this, 5 minus 1 is 4. So I know that 132 is 4WTU, or WTU equals 132 divided by 4. What is that? It looks like 33. Do we agree? Yep, I think so. Now, why did I solve for WTU? That's weird. Because in the second equation, you will find that you get a WTU. So 396 equals 6W times 1/2 plus TU. What does that equal? 396 equals 6W times 1/2, which is 3W, and 6W times TU is 6W TU. See that WTU? I need this one to plug in there. So let's solve. I'll plug in 33. And we're about to do some mental math. So 396 equals 3W plus 6 times 33 is, looks like 18, 6 times 3, 198. If I subtract 198 from both sides, I get that 3W equals, let's see here, is it 198? And W equals 66 miles per hour. That's a pretty hefty wind. The wind is 66 miles per hour. Now the last thing that I can use is that I know that the plane is 5 times the wind. So if I multiply this by 5, I get that the plane is 330 miles per hour. And our answers are correct. So that, my friend, is problem set 36.